So Newton's first law has done, Newton's second law has done. Now comes to the Newton's third law of motion. Okay, so this law is the last part of the three laws of the motion. So here what does it cover? So the Newton says that when one object exerts a force on other object, the other object also exerts an equal and opposite force on the first one. Yes, so like if somebody is forcing a body and the other body is also forcing the same body in the opposite direction. So this is how what the Newton's third law says, that every action has an equal and opposite reaction. Yes, for example, like we are walking. So how does we are walking? Actually, we are exerting a force on a ground and we are pushing the ground in the backward direction. Like we are walking, so we are stepping our foot in the forward direction and pushing the ground in the backward direction, that we are forcing it in back. So now this ground in return actually forcing us to move in the forward direction because equal and opposite force is applied. If you are pushing it in a very large force, okay, the force value is large, like when you are running, so you are applying a large value of force. Now in return again the ground is applying a force to you and now your speed going to increase because your force earlier was actually large. So that in return you are actually getting the same feedback. And also students, like if you are sitting on a chair, okay, so if you are sitting on a chair, now you are exerting a force in a downward direction. Am I right? Okay. So why does not this chair fallen down into the ground? Yes, because when you are applying a force into the downward direction, the ground is also applying a force into the upward direction and that balances the force. Here again we can say that every action has equal and opposite reaction. Equal means the magnitude here, magnitude value is equal, okay, and opposite means opposite direction. Opposite here gives the sense of direction, that the direction here is opposite. Okay, this is what the Newton's third law says, and you need to keep in mind this actually statement, and this statement is very good. Even lots of funny incidents happen on this statement, that every action has equal and opposite reaction. Like if somebody is slapping you, so you need to slap him again because equal and opposite reaction should be there. Okay, so this is a joke apart. So this is the third Newton's law, and you need to keep in mind that whatever observation you are going to take around you is actually working on these laws. Now we are having lots of examples on the basis of every action has equal and opposite reaction. So here is the one more example, that when you are actually jumping out from any boat, okay, supposingly you are on a boat and you are jumping out of it. Okay, so now when you are jumping, you are actually providing a force in the backward direction. So you can see that you are providing a force here on the object, that is boat, and that boat is actually shifting in the backward direction, and then only you would be possible to jump in the forward direction. Okay, so this is how the boat example works. And one more example like this, like if two players like collide each other and they are actually forcing each other, and if the actual equilibrium value of the system, like two bodies whose are not having the equal mass, okay, and the velocity and acceleration also is different at this pace, but now because the equilibrium at this point, that when they collide to each other, now after collision they would apart with equal and opposite force. Okay, so this is how we can measure that the observations around us following this Newton's law of motion, okay, the third law of motion. Okay students, so what is third law of motion? It predicts here are some values that you need to learn, that action and reaction both are opposite to each other, okay, and the value here, magnitude, would be the same. So we can say that both forces acting in opposite direction. Yes, definitely, then only you can say that this law works. Okay, but both forces occurs on different bodies. Yes, there would not be a single body. Like I have given you the example of foot. So here are also two bodies. One is ground and one is foot. When two balls are colliding each other, so after collision they will move apart by equal and opposite force. So we can say that here also there are two bodies. When somebody is jumping out of the boat, okay, now after jumping here, the two bodies are working, that one is the person and another one is the boat. Okay, so here in all these examples you can actually see that the forces are acting in different direction. That boat is shifting here and the man is jumping here. Okay, you are moving forward and you are pushing the ground in the backward direction. Okay, but two bodies are working in all conditions and the force that is applied here will be equal. Whatever you are applying a force on an object, the object is also applying the equal and opposite force to you. Okay, so now these points keep in mind, students, that both forces act in opposite direction and both forces are equal, and actually there are two bodies on which this phenomena works. Students, as you got to know that every action has equal and opposite reaction, right? So according to the third law, we get to know that the force of one body will be equal to the force of the different body. But acceleration value may differ because of the different mass. As I have told you that the value is applicable on two objects. Every time there would be two objects, and you know that the two objects are not having equal masses. Maybe they are having equal masses, but in most of the cases we would not see any single mass object like they are having equal value. It would not be possible in every case. Fine. So here, like a foot, in case of that, we are pushing the ground in the backward direction and the ground is pushing us in the forward direction. So here we can say that F1 and F2 are here. But these F1 and F2 would be equal because force on one body and is equals to force to the other body. This is what the third law of motion is actually saying. So we can actually write that F1 would be equal to minus to F2. Okay, so that leads us that the minus sign here predicts the opposite direction. Okay, like the directions are opposite, there is not such a value that the negative term is working here. No, but the direction is shown by the negative sign here. Fine, students. Now, as you can see that F1 would lead us to the M1 mass and A1 acceleration, F2 M2 mass, A2 acceleration. That simply means that if there are two objects, okay, and they are actually working on the principle of the Newton's third law that every action has equal and opposite reaction, like they are colliding and after that they are moving with a certain force, and the force value would be equal for them because they are on the basis of the third law of motion they are working. Fine. So F1 would be equal to the F2. Here the mass of this body is M1. So we can say that M1 multiplied by A1 because it is moving with the value acceleration of A1 here. And in this case M2. So we can say F2 would be M2 multiplied by A2. Now this body is moving here with the acceleration value of A2. Fine. So according to the mass, the acceleration value would work. If the mass is less, okay, so acceleration will be more because it would be lightweight and lightweight would be working with the more force. And now because we need to maintain the force value equal, we need to keep them equal according to the law. It is actually equal. Now, because they are equal and the mass of the first body is less, so according to that force, we need to maintain the value of acceleration because force is equals to mass multiplied by acceleration. Now, this automatically make the value of acceleration more. And here also, the value of M2 because it is more comparative to this one. So, the acceleration value of this body would be less compared to the previous one. So this is how the third law of motion actually working, that if one body is having less mass, so acceleration value of it would be more, and the value of mass of another body is more, then our acceleration would be automatically less. Okay, इसको आप ऐसे समझ सकते हो, like it is very easy to throw a small lightweight stone and it is very tough to make a big rock to throw anybody. Okay, so the acceleration value will work according to the mass of an object.